Hey there, and welcome to the Explainer. That device in your pocket, the one that's basically your connection to the entire world, yeah, there's a very good chance it's running Android. It's the operating system that powers literally billions of phones, tablets, and watches. But have you ever stopped to think about what's actually going on under the hood? You know the drill. You tap, you swipe, you launch an app. It all just works. It feels so simple. But underneath that smooth glass screen, there is a whole universe of code, rules, and messages flying back and forth to make it all happen. So today, we're going to pull back the curtain and take a look. To really get Android, you have to think about it in layers, kind of like a digital layer cake. It's a massive, open ecosystem, and that open part is absolutely key. And for a long time, every new version came with a delicious dessert code name. So let's grab a fork and dig in. Okay, so before we can really dissect an app, we first have to understand the world it lives in. Because Android isn't just a single piece of software. Not at all. It's a huge, customizable platform. Remember these? From cupcake and donut all the way to Oreo and pie, this list is a fun little trip down memory lane. It shows just how long Android has been growing and changing right out in the open. The first commercial phone actually hit the market way back in 2008, and it's just been a whirlwind ever since. Now, that term open source is the real secret sauce here. It's the key to Android's world domination. What it means is that the source code is public. So any company, whether it's a giant like Samsung or a tiny startup, can grab that code, change it, and build their own phones around it. That's why there's such an incredible variety of Android devices out there. All right. Time for the main event. Let's put on our digital lab coats because we're about to perform an anatomy lesson on a typical Android app to see what really makes it tick. Believe it or not, every single Android app is basically built from 4 essential components. You can think of them like this. You've got the blueprint for the whole project, the screen that you actually see, a silent worker that does jobs in the background, and a messenger that runs between all of them. Let's break each one down. First up, we have the blueprint. It's a file called the Android Manifest, and this thing is critical. It's like the app's passport. It introduces the app to the Android system. It lists all the other building blocks and, really importantly, it declares what permissions the app is going to need. You know, like access to the camera or your contacts. It sets all the ground rules before anything else can happen. So, what part of the app do you actually see and touch? Well, that's called an activity. Any single screen is an activity. Your Gmail inbox. That's an activity. A settings page, also an activity. But what happens when you start playing some music and then switch over to check your email? The music keeps going, right? That's a service. It's that silent worker doing its job in the background with no screen at all. It's this whole onstage versus backstage idea that's so fundamental. Okay, but if you have all these separate pieces, like activities and services, how do they talk to each other? Well, they send messages called intents. You can think of an intent as a request to do something. It's basically the nervous system of the app, carrying signals from one part to another saying, hey, start this screen, or play that song. And this gets really cool, because there are 2 kinds of intents. An explicit intent is like sending a sealed letter to a specific address. It says, hey, second activity in my app, wake up. But an implicit intent is more like shouting into a crowded room, can anyone here show me a map of this address? And that's when Android finds all the apps that can handle maps, like Google Maps or Waze, and lets you choose which one to use. So clever. So we've seen how an app is put together, but that app doesn't exist in a vacuum. It lives inside a much, much bigger structure, the Android operating system itself. And, you guessed it, it's also built in layers. Okay, let's build this from the ground up. At the very bottom, the foundation, is the Linux kernel. This is what talks directly to the phone's physical hardware. It manages security, memory, the really low-level stuff. On top of that, you have libraries and the Android runtime, giving apps essential tools. Then you have the application framework, which manages things like notifications. And finally, sitting right on top of this whole stack are the apps you use every day. Every layer depends on the one below. So with all these layers and apps from all over the world running on your phone, a really big question comes up, right? How does the system keep everything secure? What stops one bad app from stealing all your data or messing up your phone? The answer is a brilliant idea called a sandbox. Think of it like this. When you install an app, the system puts it in its own little box, its own private space. By default, it can't see or touch anything outside that box. Not your contacts, not the internet, nothing. If it wants to do anything useful, it has to specifically ask for permission. And you, the user, are the gatekeeper who gets to say yes or no.
Okay, so we've got the theory down. But what does this actually look like when a developer is writing code? How do these ideas turn into something you can actually tap on? Let's take a quick peek. So let's say a developer wants to put some text on the screen. In a layout file, they'd add something called a text view. But look closely here. Instead of just typing the words "good morning" directly, they're creating a reference, a pointer, that says @string/message. It's basically telling the system, hey, go look for the actual text somewhere else.
And this is where that pointer leads. In a totally separate file, that little MSG reference is defined, and it's linked to the text, "Good morning." Now, why do this? Well, it's genius. If you want to translate the app into Spanish, for example, you just swap in a different strings.xml file. You don't have to touch the layout code at all.
And when you finally run the app, the Android system does the magic. It looks at the layout, sees that pointer, goes and finds the right text in the resources file, and boof, "Good morning" appears on your screen. It's a simple idea, but it's incredibly elegant and efficient. So the whole journey for a developer kind of boils down to 4 main stages. First, they set up their tools. Then they get to the creative part, writing the code and creating all those resource files we just saw. After that comes a whole lot of testing. And finally, they package everything up into a little file called an APK and publish it for all of us to download.
Whew, okay. We have covered a ton of ground, from tiny little code snippets all the way up to the entire operating system. So let's zoom out one last time and talk about why all this stuff actually matters. If you take one thing away from this, let it be this. The whole system is designed to be modular. Having separate building blocks, having a layered architecture, separating code from content, this is Android's superpower. It's what makes it so incredibly flexible and powerful, and it's why it can run on so many different kinds of things. And that leads to a pretty mind-bending final thought. We started this journey with phones, but Android is already everywhere. In our cars, on our TVs, on our wrists. As this ecosystem keeps expanding, just think, what new kinds of activities will we interact with? What new services will be running silently in the background of our lives? And what new intents will connect all these devices in ways we haven't even dreamed up yet? The anatomy we explored today, it's really just the beginning. Thanks for watching.